Welcome to Ride-On Academia. We are still on our series on differentiation, okay? And then today we are going to be looking at maximum point, minimum point, and the inflection or the turning point, okay? Now you can look at, there's a diagram on the board, there's a sketch or a graph on the board where we have our points A, B, and C. Alright, so I'm going to be identifying on this graph our maximum point, minimum point, and our inflection point, and also how we can be able to solve to find out these various points. Okay, now our point A, okay, our point A is what we refer to as the maximum point. Okay, at the maximum point, this our point A is called the maximum point. Then our point B is called our minimum point, and then lastly our point C, you can see it's on the X graph, like it's on the zero. It's on the zero, right? So it is neither maximum nor minimum, it's in between, it's on zero. So at this point we call this the inflection point, or the turning point, or the saturation point, or the critical point. Okay, but literally here I'll be calling it our turning point or inflection point. Okay, and at this point we can say our equation is equal to zero because it's on the zero axis. Okay, now we're going to be seeing how we can solve using differentiation to get the value of our maximum point, minimum point, as well as our inflection point. Okay, now in getting our inflection point, what we'll do here is we are going to differentiate once. Okay, we differentiate once and then equate our answer. Now we have seen in previous videos, we have seen how to differentiate. Okay, so when we say we differentiate, I think we're not new to that, and if you've not watched that video, please do well to go and watch the video. All right, now we're going to be differentiating. Okay, we'll differentiate the first time and then equal our answer to zero, and then we'll solve. Okay, when we equal our answer to zero, we are saying at the turning point. Okay, since our answer will be zero, we equate our answer to zero, and then we'll solve to get variables, and then to know our maximum and minimum point, we have to differentiate again. All right, so in this case, when we want to get our maximum point or minimum point, either of the two, okay, we'll have to differentiate again, and then we'll substitute. Okay, when we substitute, if the value of our differentiation, our x, if our value is maybe negative, let's say -2, -3, then we can assume that's the maximum point. Okay, that's the rule, that when you differentiate again and then you substituted, if your answer is negative, then that value is for the maximum point, and then if your answer is positive after you have differentiated again, if your answer is positive, that value is for the minimum point. Okay, so we're going to be doing all this explanation. I'll be using the equation to illustrate perfectly. Okay, now we are asked to find the maximum and minimum value of the function y is equal to now we are asked to find the maximum and the minimum values, okay, for x and y. All right, I'll be doing that for x and for y. We'll be finding the maximum and the minimum value for this function. Okay, like I said, the first thing we'll do in this case, when we want to find our maximum and minimum value, the first thing we are going to do is that we're going to differentiate the first time. Okay, equate our answer to zero, and then solve for the values of x, the possible values of x. All right, and then we differentiate again to determine our maximum and minimum point. So the first thing we'll do are the y, the x, differentiating the first time. Okay, when we differentiate, we'll be having 6x squared. Differentiate, we're having -6x, and then lastly we're having -12. Because this is a constant, it will become 0, right? So we are left with this. Now we have gotten to this point. Like I said, when we differentiate the first time, we have to equate our answer, that is this one. We equate it to 0. All right, so from the first place we can say our 6x squared minus 6x minus 12 is equal to 0 at turning point. Okay, at turning point, the whole of this expression, you can see it from the graph, the whole of this expression will have to be equal to 0, and this is the only way we can be able to get the possible values of our x. All right, now let's solve. The first thing we'll do, if you can see, this is going to be leading us to a quadratic equation. we've dropped videos on quadratic equations so that we don't get lost. If you've not watched our videos, please do well to do so. Okay, now coming back to this, we have to solve, okay, for our quadratic equation. So the first thing I'll be doing is that I'll be reducing to the lowest term. I'll divide all through by 6. Okay, 6 is common, so we can divide all through by 6. So we'll be having that x squared minus x, right, minus 2 is equal to 0. Now I'm going to be applying the factorization method very quickly. Okay, we'll be considering our middle term, which is minus 1, and now we'll be considering the product of our first term, the coefficient, and our constant. Okay, here our coefficient is 1, and then we have minus 2, so we are having minus 2. All right, now we're going to be looking for two numbers so that when you multiply them, you have minus 2, and then when you add them, you have minus 1. All right, so the factors of 2, very quickly, we have, since it is a minus, that means one of the factors must have the minus sign. We have minus 1 times 2, and then we have 1 times minus 2. So to know what to be using here, we have minus 1 as our check. Okay, now minus 1 plus 2 is going to be giving us 1. What we need here is minus 1, so we're going to check the next one. Plus 1 minus 2, then we have minus 1. So we're going to be working with this. All right, we're going to be working with our second factor. So expressing this using those factors we've gotten, minus 1x, okay, plus 1x, right, plus 1x or x is still the same thing, plus x, and then we have minus 2x minus 2 is equal to 0. So by factoring out, okay, 2 by 2, 2 by 2, we have our x squared. Let me bring it closer. 2 by 2, 2 by 2, right? So this together, we have x to be common. If we bring out x, we are left with x plus 1. For the next 2, we have minus 2 to be common, if you can see. So we bring out minus 2, we are left with x plus 1. So they prove that our factors were correct, is that what we have in our bracket must be same. Mind you, is equal to 0, right? And then we'll solve. So we're bringing this x minus 2 or x plus 1 to be equal to 0. For this to be multiplication, like I said, it means one of the contents must be 0. So we'll be assuming that either x minus 2 is equal to 0 or x plus 1 is equal to 0. Right. So in solving, we'll be having that making x subject of the formula, we take our minus to the other side. We have that x is equal to 2, or our x in this case, when we take 1 to the other side, becomes minus, right? X is equal to minus 1. So let's rearrange. X is equal to minus 1 or 2. Yes, but we are not yet through. What we have done here is that we have gotten the possible values of x. All right, we have gotten the possible values of x, but we don't know if it is for the maximum or the minimum point. Yes, we have gotten the possible values of x for this function, okay, on the graph. We have gotten the values of x, but we don't know if these values should be for the maximum value of y or the minimum. So what we need to do to be sure is that we have to differentiate from here. All right, we differentiate again. Mind you, this was where we differentiated from to come to this place, right? So we'll differentiate this person again, and then we'll substitute these values. All right, now I'm going to be taking notes gradually. I'll be taking off this side. All right, okay, now if you want to be sure, right, so we have to differentiate again. So in this case, we'll be saying we are doing the differentiation again. Okay, we are differentiating again. This is our second differentiation from this point. So in differentiating 2 times 6, we'll be having 12x. All right, just 1, we'll be having minus 6. Now this person is going because it's constant, so we are true. This is our second differentiation. So what we are going to do here is we are going to, like I said, we want to know, we have gotten our possible values of x, right? We want to know the values at which they correspond for y. Okay, so we are going to be substituting for x. What we do, we substitute for x, okay, for minus 1. In the case where x is minus 1, we substitute here. That we'll be having 12 minus 1 minus 6. All right, we'll be having what? 12 times minus 1, we have minus 12 minus 6 to be equal to minus 18. Now this rule applies that when we differentiate again, Okay, when we differentiate again, if our answer is negative, then we call it the maximum point. Okay, if our answer is negative, this is our maximum. We have gotten our maxima, okay, or our maximum point. Okay, now let's go for the next one. We are having that 12, okay, x in this case is 2 minus 6. So expand, will be having 24 minus 6, and that is giving us positive 18. And now the rule holds that since our answer here is positive, then we are at the minimum point. Mind you, this is not the value of y. We're just doing a test to know our maximum and minimum point. Okay, it's not the value of y. Don't get confused. We have not yet gotten the value of our y as at here. If we want to get the value of y, what we need to do is that we're going to substitute these values, okay, the value of our x, in the main equation, in the main function, to get the value of our y. What we just did here was a check to get our maximum and minimum point. Okay, so I said when we differentiate again and our answer is negative, okay, we have gotten our maximum. Negative for maximum, positive for minimum, don't forget. All right, so if we want to get the value of our y, okay, what we need to do is that we're going to be substituting into our main expression or our main equation. All right, so I'll still be wiping off this side. All right, so to get the value of our y when x is equal to minus 1, we are going to substitute to the main equation. Okay, this very one, the one that was not yet differentiated. Okay, to get the value of our y when x is equal to 1, our y will be equal to 2x cubed minus 1 cubed, because we are assuming that our x is minus 1, right? And then for the next one we have minus 3 times minus 1 square, and then minus 12 times minus 1, and then lastly plus 8. Okay, so our y will be giving us minus 1 cube is minus 1, so we have minus 2. Minus 1 square is 1, so we are having minus 3. Minus 1 will have positive 12 and positive 8. So we are going to be having 15 as a value. All right, we are having 15 as a value when our y is equal to 15 when our x is minus 1, right? But we're not yet. Okay, so we have gotten our 15, right? And like we said, this was our maximum. Okay, that was the maximum value. You can see that when we imputed, we got a positive. Okay, so it's going to be above the graph, okay, above the x, as that is positive y, a positive value of y. So for our next, now when our x, the next value of y we want to get is when our x is equal to 2. So we'll still substitute into the main equation. We'll be having that y is equal to, in this case our x is 2 raised to power 3 minus 3 times 2 raised to power 2 minus 12 times 2 and plus 8. So let's solve. Expanding, 2 raised to power 3 is 8. 8 times 2 we have 16. Okay, 2 raised to power 2 is 4. 4 times minus 3 is minus 12. And then for this we have minus 24 and then plus 8. Alright, so to solve this, we'll be having our answer to be minus 12. Alright, so this is now our minimum value of y. Alright, we'll be able to get, for when x is minus 1, we have gotten that our y is 15. And then when our x is 2, we've gotten that our y is minus 12. You can also decide to, let's say, we can also decide to plot a graph for this to reflect both the maximum and the minimum point. Okay, so I'm going to be plotting a graph for that quickly. For our x and y axis. So this is for our positive x, our positive y, right? Then we have our negative x and then our negative y. Now let's go in. When our x is minus 1, our negative should be around here. Okay, let's say this is minus 1. Our y is positive 15. So let's go. we are plotting our graph, you can see that it's at the maximum, right? And then secondly, when our x is 2, that our x is around here, let's say 2, okay, positive 2, this is our positive x, our y was minus 12, so our y was negative. We can now say this is what our graph will be looking like. All right, making it a perfect work, we have like to make it perfect maybe on your own. All right, and then point out our point b. So this is our maximum. Like when we saw, we confirmed this. Okay, when we differentiated again, we're able to confirm that this was our maximum. Okay, like I said, if we differentiate again and then we have a negative, okay, the rule is that that is the maximum point. Okay, but if we differentiate again like we did and then we have a positive, the rule is that we have gotten to our minimum point. Okay, and then we have proven it on the graph that you now see. So with this, we've come to the end of our maximum point, our minimum point, and turning point. I hope you understood our videos. Don't forget to like, don't forget to share. If you've not subscribed to our channel, please do well to do so. All right, we'll see you in our next class. Thank you.